whole journey, it again returns to the higher priority. So this is the max sublayer protocol for token bus. It's the same thing what Chinmay said. There are just some changes. This is the preamble, start generator, frame control, which was exactly same in the previous thing. The destination address and source addresses, where the destination and source address of the token is stored. Here the data is stored. The maximum is 8,182 bytes. This is the checksum and this is the end emitter. This is the token ring. It is exactly the same as token bus. The only difference is it is in the form of token ring, like in the ring configuration, not in the bus configuration. The stations, all the stations are connected from higher priority to low or irrespective of the priority in the system, and the token transmits from the higher priority to the lower priority in the ring itself. So this is a bypass relay on relay wires. For example, if there is a system, if there is a ring or a bus, and by chance, for example, there are many systems. For example, I am playing a multiplayer game. It has also example of multiplayer game, and there are 5 players playing a game. And what if one player disconnects? It is connected through one bus. What if one disconnects? So what this thing does, if one player disconnects, or there might be many possibilities due to which a system stops working. So at that moment of time, this relay, for example, the token enters from here, goes to the system, goes to the host computer, and then leaves for the next station. But this station disconnects from the whole system. So what the relay will do, the relay will bypass that host. So the token will come here and then again go to the next station. It won't go to the host because the system has realized that this part is not working. So this is the same thing, this is the same connection, relays to different stations with cable and bypass relay. So if any of one or two stations or multiple stations are not working, the relay will bypass it and the token will pass.
Can anybody tell me what is the application of token ring protocol?
LAN gaming.
LAN gaming. What else? LAN gaming is correct. Any other application? Industrial automation, process control. Remember? Whiskey plant. Yes. Third application, backbone network. All optical fiber backbone networks on ring topology. So that is the need for bypass. Okay.
So this is a token ring max sublayer protocol. It's very important from exam point of view. So this is the whole system. If you can take a picture and like
Yes. Okay.
Because it is being asked multiple times. So this is the token ring operation. As I said, when the token comes to A, then it goes to B. It takes the address and then goes to B. Then it again takes the address and goes to C, and again takes the address and go to D. So it completes the cycle from higher priority to the lower priority. And this is a video how Ethernet works.
So you have your home network, whether your computer, network-connected printer, smart appliances, all connected to your router. Have you ever wondered how your computer knows to send your document to your printer and not your light bulb? Let's take a look. Please note, this video simplifies some concepts for easier understanding. If you need an accurate documentation, please see the description below for links. The internet is comprised of multiple layers, and today we're talking about one of the lowest ones, Ethernet. If you don't know what this means, that's fine, just tag along and it will all become clear. To understand how your local network works, we need to go back in time about 30 years. Back in those days, computing hardware was rather expensive. Instead of the current setup where we plug everything into one router, a much different system was in use. All network-connected hardware had to be linked up to one long coaxial cable. At any given time, only one device could send data over the network, so the system had to be designed around that. When a computer wanted to send data, it first had to shout a special set of bits on the network, which basically equates to "Everybody please be silent, I want to send something." If two devices did this at the same time, they would detect this conflict and wait a random amount of time before trying again. This initial sequence of bits is called a preamble. Once a device has successfully gotten their preamble out, they could then send data over the network. In order to ensure that every device gets a chance to send data, the amount of data they could send was limited. If they wanted to send more data, they would have to split it up into multiple pieces called Ethernet frames and send them one by one. To locate their target, every network device had a unique number called a Media Access Control Address, or MAC for short. MAC prefixes are assigned to hardware vendors, and each network chip or card gets a globally unique address. These MAC addresses were used in Ethernet much like addresses are used on envelopes. After the preamble and a short pause called the start frame delimiter, devices had to send the MAC address of the target computer followed by their own MAC. If they didn't know the destination MAC, or they wanted to send something to every machine on the network, they could use a special broadcast MAC of all Fs. This enabled machines to advertise services such as print availability or file shares to other devices. Regardless of the destination MAC, however, these Ethernet frames may in some cases be sent to all machines on the network. In other words, you cannot rely on the correct MAC address for security. This is true even with high-end data center equipment. Following the MAC addresses, the Ethernet frame must also contain one more field called the ether type. This field is a bit tricky because it can be used for two different purposes. If the number in this field is 1500 or lower, it indicates the total length of the Ethernet frame. If it is 1536 or higher, it indicates the type of data contained within this Ethernet frame. Nowadays, it is typically used to indicate the contents of the frame rather than the length. After all this addressing information, we are now finally able to send some data over the network. On a typical setup, this information is limited to 1500 bytes, which is then followed by a so-called checksum. The checksum verifies that the contents of the frame have not been corrupted in transport. That's it. The frame is now sent, and after 12 bytes of silence, the race for the preambles can begin again, and more data can be sent. If you come back to the present, not much has changed. Sure, we have dedicated cables for our devices, and we have smart switches and routers that can communicate with multiple devices at the same time, but the Ethernet protocol itself hasn't changed much. Apart from some carrier-grade networks, we still use the same frame structure for our local communication. If you want to take a look at Ethernet in action, I recommend you install a program called Wireshark, which lets you look at the traffic on your own computer. As you may notice, Ethernet is a local, so you have your own.
Just pause it. All of you, please install Wireshark in your laptops because that is going to be our last experiment. You will be able to see real-time TCP/IP packets moving on the network that you are connected. Okay? Because it will require admin access, you will not get to see it here in the college. So it is best that you install it in your laptop. I will give you a demonstration, but then you will be able to see it on your own laptop. Clear? So this is a very, very significant tool.
So you have your home network with your computer, network connected printer, smart appliances, all connected.
The application of Ethernet.
Most of us go about our busy day blissfully unaware of the technology standards that make all of it possible. Take the IEEE 802.3 standard, Ethernet. For a lot of people, it's just the wire that plugs into their computer, something IT talks about. But Ethernet is in a lot more places than that. For instance, without it, your smartphone wouldn't be very smart. All the web services it uses would disappear. Maps, Yelp, Facebook, Twitter, and you'd be left with just a phone. Your car's data services, like maps and traffic, gone. Even our power infrastructure uses Ethernet to help it work every day. Of course, your routers, switches, and other network devices could still be on, thanks to Power over Ethernet. Yes, its implementation permeates all that, plus medical devices, banking, avionics, robotics, emerging audiovisual connections, new types of hard drive storage, even the International Space Station uses Ethernet. Even though most people don't think about it, Ethernet and new uses for it are expanding, touching more and more of our lives every day. That's why there's such a demand for qualified engineers to invent, develop, and implement new Ethernet innovations. In fact, the IEEE Standards Association, the group that oversees the IEEE 802.3 Ethernet standard, wants everyone, engineers and inventors, to work with them and become part of this future. Recently, they held a worldwide contest to find new ideas for Ethernet, and you know who won? It's Mario Ailman, and his idea involves the use of Ethernet to enable high-speed access in remote population centers, places that would otherwise not be able to afford them. Mario's idea uses Ethernet via fiber links to backhaul data generated by high-speed wireless service. These 5 GHz outdoor access points can cover a very wide area and connect the citizens they serve through many different types of devices and services that are then connected to the network via these fiber links. Now, using Ethernet for telecommunications backhaul isn't new, but this implementation with wireless reduces the cost substantially compared to other transport modes, putting it within reach of many otherwise isolated communities. This idea is already being deployed in places like Chiriquí, Panama, where this antenna array serves that community today. By bringing the benefits of internet access and other high-speed communication services within reach of these communities, this idea can help the people in those regions enjoy the social, educational, and economic advantages that it brings. To find out more about the work of the IEEE Standards Association and the entire family of IEEE 802 working groups, and how you can be a part of the global evolution of Ethernet, come see us at standards.ieee.org.
Done?